Hey you guys, I did not realize I'd hit start that fast. I apologize. I am eating some Cheez-Its. Yes, I have a slight Cheez-It addiction. Today we're going to go ahead and take notes over volume. So this should be the next page in your packet. If you've been following along with my checklist, you would have noticed the page right before this, I said, hey, just trash this one. I did realize it was exactly the same as your surface area notes, so no use in holding on to that. So we're going to go ahead and look at volume. I gave you an intro video to volume. Hopefully you watched that before this. You know how to find volume from elementary school. Length times width times height, or the area of the base, depending on what the base of your shape is, times the height. In 6th grade, this is standard 2, and it basically says that you should be able to find the volume of a right rectangular prism, any of these shapes, using fractional edge lengths. That's why you see fractions on most all of these. Yes, fractions, okay? Don't you get intimidated by those fractions. We've been working with them. I know you've got this. The only thing that you may have to recall is finding or remembering how to take a mixed number and make it improper. Alright, so I've gone ahead and colored in a little bit of this, so feel free to do that with me. You guys can doodle these up. I thought they would look good. You'd enjoy them. Volume is the number of cubic units needed to fill a space. So is the number, and I'm going to try to fit this on these little lines here. Number of cubic, meaning to the power of 3 cubic units needed to fill a space. Okay. And then you guys can come back later and color this in if you want. There are 2 different formulas for volume, and you have seen, and you should be familiar with this one right here. That's the one that you're familiar with. Length times width times height. So for example, the length of the box here times the width of the box here times the height of the box up here, which in my intro video you should have seen that I actually used a sample box, and I could use the box of my Cheez-It box here, but I'm not sharing my Cheez-Its. I'm not sharing. The other formula you might not be quite as familiar with is this one over here, and notice that that B is actually capitalized. That's because that B is not just for base. It actually stands for area of the base. So it's implying to find the area of the entire base. Most of the time this formula right here will be used when your base is a triangle. Like if you were to find the volume of a triangular prism. Well, if the base is a triangle, you wouldn't do length times width. You would have to do that length times width divided by 2, okay? So that's where things can get confusing. But we're just going to be working with rectangular prisms, so you shouldn't have to worry about it. But sometimes you might be thrown for a curveball and be told, hey, the area of the base is this, and the height is this, find the volume. So you would just take the 2 and multiply them together, okay? Alright, so let's look at number 1 together. On number 1, we're being told that every single one of these cubes is 1/3. That's what we're being told. So that means that we actually need to figure out what the length, the width, and the height is. So for example, if each one of these is 1/3, I need to count and see how many thirds there are right here. So I count 1, 2, 3, 4, 5. There are 5 thirds. And since it says centimeters, I'm going to go ahead and put the units as centimeters. Now I will tell you out to the side, this is the same as 1 and 2/3 because 3 will fit into 5 one whole time with 2 out of 3 left over. We don't need that, but I'm going to write it so that you can see it, okay? On our width, we need to count and see how many thirds we're looking at here. We're looking at 1, 2, 3, 4. 4 thirds here. And I'm going to add centimeters. If we were to make this a mixed, or say we were given the mix to begin with, 3 goes into 4 one whole time with 1 out of 3 left over. We don't need this, but later on, we might be given something like this and have to change it to improper, okay? Now we need to find the height. The height is 1, 2, 3. 3/3. You guys should know that is 1 whole. Okay, now to find the volume, we're going to use this formula right here that you guys should already be familiar with. Let me grab a different color. So we're going to use V for volume equals length times width times height. And since we're just multiplying them all, it doesn't matter what order we put them in, because if you recall the commutative property, it says it doesn't matter the order in which you multiply, you'll get the same product. So we're going to take and we're going to multiply 5/3 times 4/3, and I'm going to leave, instead of making this 3/3, I know that's 1 whole. So let's just make it 1/1. That's the same thing. That's the same thing. So now we're multiplying straight across. You multiply your numerators. 5 times 4 is 20. 20 times 1 is 20. And then you multiply your denominators. So 3 times 3 is 9. And 9 times 1 is 9. Alright, so we have 20/9. And you guys know we can't leave that like that. That is improper, and it needs to be simplified. So we're going to come down here and divide. 20 divided by 9. Don't use a calculator for this because you're going to get a decimal, and we need a fraction. So how many 9s fit into 20? Well, I know I can fit 2 of them in there. 9 times 2 is 18. And when I subtract, I'm left with 2. So to make our mixed number final answer, 2 whole times with 2 out of 9 left over. And our units are centimeters. And if you recall, they are cubic. It's cubed. Centimeters, cubed. So a little different. It's not squared this time. It is cubed. So here is our final answer. Okay, let's go ahead and look at number 2. And then I'm actually going to cut this video off and have a part 2 for the next page. Okay, so we'll do this the front side just like our surface area. So number 2, we already have the dimensions for the length, the width, and the height. But one of them is a mixed number. We can't work with a mixed number. He's not going to cut it. We need to make him improper. So I want to do a little side note right here, and I want to say, make all mixed numbers improper. I'm going to use the symbol for numbers, just so we don't have as much to write. So the only one that needs to be changed here, ooh, poo, I just marked it myself, you guys, is 1 and 1/4. So if you remember, we do denominator times the whole number. 4 times 1 is 4. Then we add our numerator. So that's 4 plus 1, which makes 5, back over the same denominator. So 5/4. Now we can go to working this problem out. So my formula is length times width times height. And again, it doesn't matter what order I multiply, I'm going to get the same product. So I have 5/4 times 1/2 times 3/4. 5 times 1 is 5, and then 5 times 3 is 15. 4 times 2 is 8. 8 times 4 is 32. So now I have a fraction. I just need to look and see, do 15 and 32 share a common factor? Is there a number that will go into 15 and into 32? And you know what? I cannot think of a single number they share. So that's my final answer. I need my units, meters, and it's to the power of 3. It's cubed. And that's my final answer. Alright, if you want, you can go ahead and trim this and paste it in if you want. It's the next topic in your notebook, so remember to write that topic down. The title is volume, and then I'll have part 2 for you to watch, and it will be notes over the next page. Alright?